We're going to take a look at rationalizing the denominator. A quick review on simplifying a radical. We want to look for perfect square factors in the square root, the number under the square root, or just a quick and easy way to do it is to make a factor tree. So 75 can be broken down into 3 times 25, and then we want to break these down to prime numbers. So I have 3 times 5 times 5. For square roots, we want to look for a pair of the same number. So here I have 5, so this would simplify to 5 square roots of 3. For example 2, I have the square root of 10 times the square root of 6, which is the square root of 60, or I could just leave it as 10 times 6 because my next step is going to be to break it down. So that would be 5 times 2 and 2 times 3. So I have a pair of 2's. So a 2 comes out, and then 5 times 3 is 15. So 2 square roots of 15. On example 3, that would be the square root of 7 times 7. So I have a pair of 7, so the square root of 49 we know is also just 7. So rationalizing the denominator is when we move a root from the denominator of a fraction to the numerator. And it's really making sure that the fraction is, the denominator is a rational number. So remember that a rational number can be written as a fraction and an irrational number cannot be written as a fraction. So to be in simplest form, the denominator should not be irrational. It's okay to have, this should say radical in the numerator of a fraction, but never the denominator. So in this 1 over the square root of 2, I have a radical in the denominator. That's not okay. I'm going to be able to fix that really easy. I'm just going to multiply the numerator and the denominator by 1. So I'm going to multiply by 1, which we know is fine because of the identity property, but I'm going to be careful to choose a name for 1 that is made out of the denominator. So I'm going to use the square root of 2 over the square root of 2. Isn't that 1, a number divided by itself? But it's going to accomplish the goal of rationalizing the denominator. So now the denominator is no longer going to have a radical in it. Because now if I multiply these fractions, 1 times the square root of 2 is the square root of 2. And then along the bottom, the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So 1 over the square root of 2 is equivalent to the square root of 2 over 2, which is in simplest form. Sometimes the radicals that we're dealing with aren't simplified yet, so we need to go back to what we did at the top. So I'll come over here and simplify the square root of 18 and the square root of 12. So the square root of 18, that could be 9 times 2, 3 times 3 times 2. So I have a pair of 3's. So 3 square roots of 2 is the numerator simplified. And then I'll come over here and simplify the denominator. And that's 2 times 2 times 3. So I have a pair of 2's, so 2 square roots of 3. So when I bring that back, I see, oh, I have a problem because I have a radical in the denominator. So to clear out the radical in the denominator, I don't need to multiply by the whole denominator. I can just use the radical in the denominator. See, that's 1 square root of 3 over square root of 3. That's using the identity property, which allows it. So now when I multiply it, voila, it's going to rationalize the denominator. So look at the numerator here. 3 square roots of 2 times the square root of 3 is 3 square roots of 6. And then in the denominator, 2 square roots of 3 times square root of 3 is really 2 square roots of 9, but that's 2 times 3, which is 6. Now in this problem, 3/6 will reduce to 1/2. So the 3/6 will just be a 1 over 2. So square root of 6 over 2. Sometimes we can have a binomial divisor or denominator. That's not going to happen so much in this unit, but just to show you how to deal with that, when you have a two-term denominator, we multiply by the conjugate of the denominator. Remember, conjugate of a plus bi is a minus bi. So here I have 3 minus the square root of 2. So I'm going to multiply by the conjugate 3 plus the square root of 2. So I have 3 plus the square root of 2 over 3 plus the square root of 2. Again, that's equivalent to 1, which makes it okay to multiply. And so when I multiply it by 1, I just get the same thing back in the numerator. But in the denominator, I'm going to double distribute. So when I multiply the 3 by both things in the second parentheses, I get 9 plus 3 square root of 2. And then when I distribute the square root of 2, or sorry, the minus square root of 2 times the 3, that's going to give me minus 2, nope, sorry, that's minus 3 square root of 2. And then minus square root of 2 times square root of 2 is minus square root of 4, which is minus 2. So that denominator is a little tricky. So then 3 square roots of 2 and minus 3 square roots of 2 make 0. And then 9 minus 2 is 7. So I have 3 plus the square root of 2 over 9 minus 2, which is 7. And that's my final answer. Notice that there's no radical in the denominator once that multiplication is carried out. So the application we're going to use in this unit is really pretty straightforward. We're going to be making fractions from our unit circle, and sometimes we're going to have a denominator that contains a radical, and that's not in simplest form. So look at number 1. I have 2 over the square root of 3. So I'm going to rationalize that by multiplying by the square root of 3 over the square root of 3. And so that gives me 2 square roots of 3 over the square root of 9, which is 3. So 2 square roots of 3 over 3 is the simplified answer. And that's really pretty much all that you have to worry about. Look at number 3. The square root of 12 just isn't simplified. So if I come off to the side and simplify the square root of 12, 6 times 2, 3 times 2 times 2, I have a pair of 2's. So that's really 2 over the square root of 3. So if I write that over here, I didn't mean to say 2 over the square root of 3, 2 times the square root of 3. So it's 1 over 2 square roots of 3. So then to rationalize that, I would multiply by square root of 3 over square root of 3. And that's going to give me, the square root of 3 over 2 times the square root of 9, or 2 times 3, which is 6. And so I have the square root of 3 over 6. A quick glance at number 5, the square root of 36 is just regular 6. So that's 12 divided by 6, which is just 2. So if there's a radical in the denominator, you can simplify it first and then rationalize by multiplying by 1.